How many atoms are in the human body? According to Jefferson Lab, which is one of 17 laboratories funded by the U.S. Department of Energy, there's approximately 7 octillion atoms in the human body. That's 7 times 10 to the 27th power, or 7 followed by 27 zeros. To put that number into perspective, there's approximately 7 billion people on the planet. If all of those people, every man, woman, and child, all had a billion babies each, and all of those people and all of those babies all had another billion babies each, you would have 7 octillion people. And that's how many atoms there are in the human body. Hello, my name is Jonathan Weppel, and today I'm going to talk to you about the evolution of our universe. And you might be asking yourself, what does the number of atoms in the human body have to do with the evolution of our universe? Well, everything and nothing. See, the elements that compose our bodies is something that we'll talk about in a little bit, but the number of atoms in the human body is just something that interests me. See, it wasn't very long ago that I wanted to be an Earth and space science teacher, and today I'll get to live out that dream for 5 to 7 minutes as I talk to you about the Big Bang, the formation of heavy elements in supernovas, and the composition of life. I'll start where the universe started, with the Big Bang. The Big Bang is the most widely scientific explanation for the beginning of our universe. According to NASA, the Big Bang occurred 13.7 billion years ago. 13.7 billion years ago, the entire universe was smaller than an atom. And then suddenly, bang! The universe expanded in every direction faster than the speed of light. It's expanding and accelerating to this day. This is what we estimate the universe looks like presently. The expanding and accelerating universe is something that was originally concluded by Edwin Hubble in 1929. It's been more recently substantiated by 2 groups of independently working astronomers at the University of Berkeley, California. They won the Nobel Prize in Physics in 2011 for their work studying supernovas. They concluded that the supernovas were accelerating away from us. And you might be asking yourself, what is a supernova? Well, I'm glad you asked. A supernova is an exploding star. What is a star? In the beginning of the universe, the universe after the Big Bang was just basically a smear of hydrogen, mostly hydrogen, and helium. These clumps joined together by gravity, and these clumps are so massive that the gravity is forcing the hydrogen together so intensely that it fuses the hydrogen together to form helium. This fusion process releases an extreme amount of energy, and this is what powers our sun. According to NASA, stars that are at least 5 times larger than our sun can die in an event called a supernova. After a star runs out of hydrogen to fuse together, it could fizzle out, but if it's at least 5 times larger than our sun, it'll then, after it's done fusing the hydrogen into helium, it'll fuse the helium into carbon, and it'll fuse the carbon into oxygen, and oxygen into nitrogen, nitrogen into iron, and once you get to iron, once the core is mostly all iron, iron is so strong that its repulsive force is stronger than the gravity that's pulling it together. So, boom! A supernova explosion. Iron atoms and every other atom that we know of, this is how they're blown throughout the universe. They're all forged in supernova events. You may have heard that we're all made up of stars. This is what they're talking about. Humans are 95% hydrogen, oxygen, and carbon. Oxygen and carbon are forged in the centers of supernovas. We are all creatures of the universe. We're components of the universe, capable of looking back at it. We're capable of learning about the universe. We're capable of understanding our locations within the universe. We're capable of communicating to one another as parts of the universe. What did I communicate to you today? I communicated the Big Bang. I communicated supernovas and the formation of heavier elements. And I communicated the components that make up life. How many bits of stardust are in each of us? Approximately 7 octillion. Thank you.